We have this problem on the board. We have an exponent tower, x to the x to the fourth equals 1728. And this problem, it's interesting for a couple of reasons, but I think particularly, first thing I want to notice is that 1728 is 12 cubed. Now, like in the previous problems with these tower problems, we want to get this to look something like a to the a equals b to the b, because then we can equate base to base, exponent to exponent, and say a equals b, and then the problem tends to become easier to solve. So to start with, what I'm going to do on the left side is raise everything, take this to the fourth power, hoping to use the fact that we already have this 4 here. Now in an exponent tower, keep in mind it's calculated from top to bottom, so we could kind of add parentheses in here and then multiply by exponent rules to the inside. And so we're going to have x to the 4x to the fourth equals, and I'm going to write this over here as 12 cubed, but we have to raise this to the fourth power as well, because we did that on the left side. So you're probably familiar with this exponent rule. If we have a to the b to the c, we can multiply inside like what we just did here, but you can also do the reverse of that. So this equals this, but then this can be done in reverse. So if you have a to the b to the c, you can pull one of these out. It's like kind of imaginary parenthesis, right? You can pull the c to the outside and you end up with, or you could pull the b, it doesn't matter. So this is equal to this, or this is also equal to this. So we'll use that here. And what we can do is we can multiply this 3 to the outside. And here we'll have, this is 12 to the 12. Now we also can use that rule on the left side. If we look at let's kind of look at this as two different pieces, 4 times x to the fourth. We can just put parentheses around it and then let's bring this to the outside. So this is going to be the same as x to the fourth inside parentheses to x to the fourth equals 12, just being very careful with our parentheses and how we're handling exponent rules. But then now we have this relationship we're looking for. If we say we'll set a equal to x to the fourth, just so it's clear to see, and we'll say, we don't have to do this, but b equals 12. So then we end up with our a to the a equals b to the b. And we can equate those two, so we can say that a equals b. So we're saying that x to the fourth equals 12. Just equating the base and equating the exponent. But then to solve for x, we can just take the fourth root on both sides. I should have given myself more space. And that's going to give us x equals the fourth root of 12. Now let's just validate that this answer makes sense. So we'll have the fourth root of 12, we're using this here, to the fourth root of 12, it's kind of ugly to look at, to the fourth, and let's not worry about the right side, let's just simplify this. Now, because I said earlier, the exponent tower, you have to calculate top to bottom, but we have this 12 to the fourth root of 12 to the fourth is just 12. So write this at 12. Now here, let's do this. Let's rewrite our 12, the fourth root of 12 as in exponent form as 1/4 to the 12th. Then using the principle used before, you can multiply this inside, and we have 12 to the 12 over 4, which equals 12 cubed. But 12 cubed is just 1728, the answer we were looking for. So that's correct.